Yeah, hey everyone, this is Dwayne with Good Works Auto and Dwayne's Diagnostics. And I'm doing a video right now on relative compression testing and battery load testing. And I got my scope leads hooked up here. I'm going to show you the results of this test on the scope. But actually, one of the reasons I wanted to do this video is to show you that you can test your own battery if you just have a multimeter. It doesn't have to be one like this, but you can actually load test your battery basically just by cranking the car over and checking the voltage on the battery while it's cranking. But and the voltage shouldn't drop below 9.6 volts. And I can show you where I'm getting those specifications. This is actually one of my ASE test books, which was published in like 2012. But I can show you on here. This is where it tells you how to do a battery load test. And says, you know, with the test connections made and all electrical loads off, crank the engine over with the starter. Starter current draw when cranking the engine over should be around 150 amps for a 4-cylinder engine, 200 amps for a 6-cylinder, and 250 for a V8. However, some permanent magnet type and gear reduction starters can draw more. Always refer to the specifications in the vehicle service manual. Battery voltage should remain above 9.6 volts. And the engine should spin rapidly. And this 9.6 volt minimum has been around for like at least 50 years that I know of. I have older automotive textbooks like from the 1970s that have this same test and those same specifications listed in it. So this is like an industry standard test that's been around for like at least 50 years or so. But yeah, I got all my scope leads hooked up, and I'll show you show you some stuff I got going on in the car. So I did have all this stuff already pulled up on my scan tool, but I forgot I had turned the key off. So I got to pull this stuff up here. It'll only take a second. A few seconds. So I'm not sure if you can see those real good on the camera, but I got the fuel pump enable command, accelerator pedal position, and injector pulse width, bank 1 and bank 2 pulled up. And the scan tool is plugged in. The VCI is plugged in. You can see the lights down there, the LED lights. And part of what you want to do, if you can do it, is go into what they call clear flood mode. And clear flood mode is basically just holding down the accelerator pedal all the way to the floor while you're cranking it. And that will disable the fuel injectors so that then you can basically get a more accurate test result. You really don't want the engine to start if possible, but you can still do the test even if the engine cranks to get a good idea of the condition of your battery. But I'll show you here. I'm not touching the gas, and I'll crank this thing over and show you what's going on here. The fuel pump enable command goes to on, and then it shows the pulse width of the injectors in milliseconds. So I'll turn it off. And now I'm holding the well, I let off it there. I let off the accelerator pedal, it goes to 0. Now I hold it down all the way, it goes to 100%. And now I'll crank it over, and you'll see those injectors aren't doing anything. See, the injectors don't do nothing. So that's what clear flood mode is. And I can show you the reason why you want that clear flood mode, or why it's better to be able to have that clear flood mode while you're doing this test. But I got the scope all set up, and I'll just crank the car normal so you can see what it looks like on the scope. Okay, car instantly started right there. I'll go back. See, that's the waveform of the car starting. This right here is the amperage that the starter motor is drawing, which went way up there to like 600 amps. And then this is it actually cranking. And then down here is where it actually gets started, where the car actually started. But you can't really see a whole lot there as far as a relative compression test. So I'll go back here and do it. Now I'll do it in clear flood mode, holding down the accelerator pedal, and you'll see it's going to look a lot different. Yeah, turn the scope on. And the car didn't start right there. See, so I got a lot longer waveform of the car actually cranking over. And there's actually a lot of cool things you can see on this relative compression test, but I'll get to that in a minute. I'll show you what the battery voltage dropped to here on the scope. Saying about 9.366, which actually that's below that 9.6 minimum voltage standard, but you're actually going to get a lot lower reading on a scope because the scope has less impedance, and it can what they call sample, but basically measure the voltage. Like it can measure it like 1,000,000 times or more faster than just a regular multimeter can. But I'll go out here and show you what the minimum voltage is on the multimeter. So right there, the maximum is 14.55. That would have been when the car actually started and the alternator kicked in and started working. But if I go here, that's the minimum voltage, 10.78, which you know, this is a newer battery on my car here. So you know, I wasn't expecting it to fail the test, but that's a test you can do that, you know, the average do-it-yourselfer or hobbyist or anyone can do to load test your battery. You don't have to have like any fancy equipment, just a meter, and you don't have to have the min-max function that this one has. It's better so you can do the test by yourself and have the meter hooked up outside of the car while you're inside the car cranking it, and then come back and look at the minimum voltage. But you don't have to have a meter that has this min-max function. You could actually run jumper leads and run the leads into the car to where you can watch the meter while you're cranking it yourself. Or if you have a helper, you know, you can have the helper outside of the car watching the meter to see what the voltage drops to. But yeah, that's one way you can load test your battery, you know, and not have to have any fancy equipment or expensive equipment, or have to, you know, pull your battery out of the car and take it somewhere. But you want to do that test when the battery is fully charged up to get accurate results from that test. But there's some things I can show you here on this relative compression waveform. You can see right there the amperage got up to about 600 amps, and it actually went over 600 amps, because I have it set on a 600 amp scale right here, and it kind of clipped it off right there. It didn't draw the rest of the spike, so it actually went over 600 amps. But that's normal. When the starter motor first tries to start, you're going to get a huge spike in amps. But I can show you down here. This is while it's cranking, the amps are about 162 amps. Which is somewhat close to what the book said. I think they said about 200 amps on a V6 engine, and this is a V6. But this engine also has timing problems, so that could actually be affecting that is affecting the compression. So that might be causing it to draw a lower amperage, because this engine actually has timing problems on one bank, so it has a lower compression on one bank. And I was actually hoping to be able to show that to you. It's not really as noticeable on this waveform. Yeah, it's not really as noticeable on this waveform, but this engine does actually have low compression on one bank, and it's not really showing up as well on this waveform. But I've done this relative compression test on this car like multiple times, and it does it showed up better on other waveforms I took. But basically, these humps here are the pistons coming up to top dead center, and that's the amperage it's drawn as the piston comes up. And once the piston gets up to top dead center, that's the amount of amperage the starter is drawn. So each one of these triangle looking shapes is a cylinder, and it's not as easy to notice on this waveform, but every other one is low. This one's a little bit lower than that one, and a little bit lower than that one. Same thing with this one, it's a little bit lower than that one. Just a little bit. It's kind of hard to notice on here, but every other one is low on here, because there's a timing problem on one bank, so the compression is lower on one bank. And I can actually pull that up and on one of the older waveforms I took on this car. I can actually pull that up and you'll be able to see it better. Maybe on this one. Maybe not. Let's see. Yeah, you can see it a lot better on this one. Right here. That one's higher, this one's lower. 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 Higher, lower, higher, lower. So there's actually a lot of information you can glean from one of these relative compression waveforms. And I was just thinking of something else I was going to say, but forgot what I was going to say. But this is the same car, same test. Oh yeah, what I was going to say is that's why you want to have the clear flood mode, so you can see the engine cranking for a longer period of time, because then you have basically more information, more of a waveform to look at to see what each cylinder is doing, and if it repeats the same pattern over and over again, which it does on this car. So you know, you don't have to use clear flood mode. Not every vehicle has clear flood mode. I think most GMs do, and pretty sure a lot of Fords do, but not all vehicles have clear flood mode. This one happens to. I just tested a F-250 diesel the other day, and it did not have clear flood mode. But I thought somebody might find some of this stuff kind of interesting. But that's a way you can actually load test your battery with just a meter. You know, you don't have to have the scope and, you know, any fancy expensive equipment, or actually even a whole lot of knowledge. If you know, you just hook the meter up to positive and negative and crank it over. So anyway, I hope that might have been helpful to someone, and somebody might have liked this video. But that's it on this one. I'll see you or talk to you on the next one.